There are other indeterminate types that we can use L'Hopital's rule to break them down. There are other types. 1 to the power of 0, or 1 to the power of infinity. 1 to the power of infinity is one of those indeterminates that we don't know the limit of from the outset. 0 to the power of 0 or infinity to the power of 0. These forms are forms when we have indeterminate. This is the case when we have f of x to the power of g of x, and f of x goes to 1, g of x goes to infinity, like the 1 to the power of infinity form, or f of x goes to 0, g of x goes to 0, f of x goes to infinity, and g of x goes to 0. All these forms are forms of indeterminate. So to take the limit of these forms as x approaches to a, what you do is let y be f of x to the power of g of x, and then take the natural log of y. This will give you natural log of f of x to the power of g of x, and the log rule gives you that this is g of x times natural log of f of x, and this becomes a 0 times infinity type indeterminate, and or infinity times 0 or 0 times infinity type indeterminate. And now you can apply the trick that we did with that type of indeterminate to evaluate the limit of y. Once we get the limit of natural log of y, when we get the limit of natural log of y as x approaches to a, then to get the limit of y, because that's what we want to find, the limit of y, we just take that c to the power of, e to the power of c, and that gives us the limit of y as x approaches to whatever a we have. In other words, the limit of f of x to the power of g of x will be e to the power of the limit of this expression. Okay, so I will do a couple more examples, 2 examples on this, similar examples, in the next 2 videos.